There. I'll be quick. Thank you all for staying this late to listen to me. We can skip a lot of this, which is good news because we've already gone through a lot of this. So I want to talk about Vault, and I'll finish off. And for me, of all of the products we do, they're all really interesting. But for me, Vault is one of my favorites. It's very close to my heart. So again, just to reiterate what I talked about earlier, we shifted away from, or certainly shifting away from static infrastructure. So the way we used to do secrets, which is what Vault is, it's a secret management solution. The way we used to do secrets in the past was we built a data center, we built a big perimeter around it, then we had like a pipe into it, and then we would control what would flow in and out of that data center through that pipe. Now, of course, that doesn't really work anymore because we're in a dynamic world where I'm going to tell you the worst joke in the world, which is, what's the difference between a public server and a private server in the public cloud? One API call. No, you see, it's a terrible joke. It'll never work. But basically, so the problem that we used to do is we used to use IP addresses for identity. Well, if you've got like 5,000 containers spinning up, it's really hard to track all of those IP addresses and then use those IP addresses, because they're constantly changing. They're coming up, they're going down, you create them, you throw them away. It's constantly changing. Now, of course, we bring up new systems. We can't really trust the networks that they're operating on. So how do we have secure secrets management in a world where we can't really trust the network? Now, it turns out that a lot of the platforms, all of these new platforms where it allows you to spin things up really quickly, already have something that we can use. They have identity providers. So if you're using AWS, they have IAM. Azure have Azure AD. Google have Auth. Kubernetes have Auth as well, and all those different types of things. And it turns out we can actually use that identity, which we can then trust, to actually provide secrets to our applications. So let me talk a little bit about some of the challenges that we have with secret management today. So quick question if anyone wants to shout out. I'm not suggesting you, but where do you think people store secrets today? Let's assume they're not using Vault. Where they might store secrets? Anyone want to have a shout out? Config files, databases, spreadsheets, someone's head, config management systems, Puppet, Chef, Ansible. You need secrets inside your configuration management code, so they end up in there. We end up with this kind of what we call secret sprawl. Secrets end up everywhere. There's no real centralized place about where secrets are. The problem with that is, if we have secrets in all of these different locations, how do we track who is accessing those secrets? You can't really do that. How do you track that someone's accessing a secret inside of a Git repository? How do you track whether someone's accessing a secret inside of a spreadsheet? How do you control who has access to all those different things? It becomes a huge problem. So the way that we solve this with Vault is to have a centralized secret management solution where we have everything in one place, and it's a very strong, hardened solution. The other problem that we have is, because we have all of these different systems, is everyone familiar with HSMs? HSM is a hardware security module. So most financial organizations use something like that. They're really expensive devices. Hardware provide cryptography. They're very expensive, not particularly performant. But there are requirements for some organizations to use those HSMs. They don't scale particularly well. Well, they do scale. You buy lots of them and you spend millions upon millions of dollars. They're sometimes difficult to interact with. They use something called PKCS 11 for the interaction, and that can sometimes be a little bit challenging. But we have all of these different systems, and I'm going to keep saying that, workflow is not technology that I mentioned earlier. It's going to be the same thing with Vault as well. So the idea is, instead of having secrets inside your application code or hard-coded in like config files somewhere or in a spreadsheet or in someone's head, we put them in a central solution. We can control who or what. I don't just mean people, I mean workloads as well. Because it's not just people that need to access systems, secrets I should say. It's your workloads, your applications need to access secrets. And we need to find a way for your applications to access those secrets in a way that doesn't put the burden on us as operators. If we all of a sudden need to burst and spin up hundreds of VMs or thousands of containers, it would be very difficult, if not impossible, to have an operator provide access to all of those different systems as they come up, to fingerprint them or to install agents on each of those systems or anything like that. So we need a zero-touch approach for applications to authenticate themselves, to identify themselves to Vault, and then be able to consume secrets from it, tightly controlled through ACLs, access control lists. So we can say exactly what system has access to what secrets, exactly what person has access to what secrets. Also as well, I mean, when you think of security, you think of encryption. Your secret management solution needs to encrypt data both at rest and in transit. Spreadsheet's not going to do that for you. Git repository is probably not really going to do that for you. And all of Vault can be controlled through the API. So Vault, like all of our products, is actually an API-first product. So everything that you can do inside of Vault, everything you hear me talk about, everything you see when I run a demo at the end, is actually all driven through the API. So I'm going to talk real quickly about how Vault works and then dig into a couple of these areas in just a little bit more detail. So this is Vault at the center. Vault is essentially like a secrets broker, if you like. It provides access to clients. It could be a person, it could be a VM, it could be a container, it could be a Lambda function, for example. We talked, I didn't understand it unfortunately, but we talked about OpenFAS earlier and functions and things like that. Vault uses a trusted identity-based system. So I've already mentioned that the cloud providers have their own identity management solutions. Kubernetes has its own authentication system as well. And we also actually have a generic method where, if it doesn't fit into one of these things, there are ways that we can have machines automatically identify themselves to Vault without any pre-putting passwords on a machine or things of that nature. So all operations inside of Vault need to be done by a privileged user. They need to authenticate themselves. What secrets they access, we tightly control. We're not saying once you're in, you have access to everything, because that would be silly. We control, well, maybe you have access to this particular key value, or you have access to generate credentials for a particular database, for example. And Vault is very strong on the types of secrets that you can actually manage. Now, quite often when you think of secrets, you just think of simple things, like a string of text, okay? That's what we would call a static secret. It doesn't really, it gets generated or created either by a person or by a machine, but outside of Vault. But Vault has the concept of what we call dynamic secrets. So the idea is the best secret is the one that nobody knows. So if your web server needs to talk to your database, then why should you insert a person in the middle who has to generate the password and then pass it to the web developer who puts it into the application? You're introducing lots of people in the chain, and that's where things start to break down. They're no longer secrets as soon as you share them. So I'm going to touch on a couple of the use cases for Vault. One is secrets management, as I've mentioned, and the other is data encryption. So Vault, one of the principles of Vault is that it is API driven. You can see here, it's a simple curl request. So you can access a particular configuration of a secret inside of Vault. You can also drive this through the CLI if you like typing on a command line. Again, if you're like me and you like user interfaces, there is one of those for Vault as well. I want to talk a little bit about the identity platforms that Vault can actually use. So imagine you're using one of these systems, Azure, AWS, Google, Kubernetes, or whatever it may be. These systems all have identity providers for each one of these systems. So when a workload spins up, you create a pod, or you create a virtual machine or a Lambda function, for example, on AWS. When that comes up, it uses the identity provider to prove to Vault who it is. At which point Vault will assign a policy to whatever it is that's requested access, assuming that it's allowed to do that. And that policy will say what secrets you're actually allowed to access. Now, when I say it's zero touch, I mean that quite literally. Without putting any passwords or pre-shared keys or anything on any of these systems, you can spin up a load of virtual machines. They'll automatically identify themselves to Vault, access their secrets. There's no person in the middle. There's no other system in the middle. And in fact, for when Vault generates dynamic secrets for things like databases, it can do that for. It can generate credentials for Azure, for AWS, for GCP, for AliCloud, etc. It can create PKI certificates as well. So, for example, you could use Vault to generate short-lived TLS certificates that maybe only live for 24 hours. So the idea with Vault is we have the idea of these dynamic secrets because we're always creating a moving target. So invariably, these credentials leak. They leak because your application is leaky. So we give a secret to an application, and the application crashes, and it writes the secret and everything in memory to like a diagnosis file, or it sends it to the logging system, or it sends it to the monitoring system. So all of a sudden, secrets do leak. It's just inevitable that it is going to happen. The idea is with Vault, because they're very short-lived, after 24 hours or 7 days or whatever it is that you define, they're no longer useful. So you've always got this moving target. So even if I was to check a log file, and there's some secret information in there from 2 months ago, it's going to be useless to me now. And Vault's very extensible as well. We're always adding new, what we call secret engines. They can be very simple, like a key value store. They can be, as I mentioned, for generating credentials for things like databases, for the cloud providers, for example, JWT tokens, TLS certificates, etc. So again, just to reiterate, so the problem with trying to do secrets management using IP-based is it doesn't scale. It's hard to manage, and it's not you shouldn't trust IP addresses, basically. It used to be great when we had 100 servers and we knew the IP address of every single one. You're going to have a lot more systems coming up and coming down all the time. If you have all of these separate systems for managing your secrets, it's expensive, because you have to develop different workflows for every different type of secrets as well. And it's a bad practice to have your secrets everywhere and have no audit trail. I can't stress that enough. Security people love audit trails to know who said what and who or what is accessing secrets. So the idea with Vault is we have a standardized workflow for accessing all different types of secrets. We have a standardized workflow for identifying yourself to the Vault platform. And we reduce the risk by defining exactly who has access to what different types of secrets. So this is a case study. We've had to anonymize these because no one wants to be named and shamed, unfortunately, but just internet company, large internet company. So imagine I have secrets on my laptop. They're from 5 different systems because my secrets are all over the place. Somebody steals my laptop, then you need to go to 5 different systems, revoke all of my different secrets. It becomes a little bit of a nightmare. Now, imagine if everything was in one centralized place. You only need to revoke one thing, and then Vault will remove access to all of those secrets. If you have what we call dynamic secrets, so I generate, let's use a database example because it's quite a good one. I generate a database username and password for MySQL, and it has a lifetime of, I don't know, 30 days, for example. At some point, I might be like, I need to revoke that right now. You can do that inside of Vault. It's a centralized place. You say, revoke that secret. Vault talks to the database and drops that user. So ultimately, we reduce costs and reduce risk. So there are some features inside of Vault that I've mentioned. So I've already talked about sort of dynamic secrets and what they are. They're ephemeral. They're short-lived. You can create lots of them. Obviously, Vault is very secure. So all of the data that Vault has to persist to the storage backend is going to be encrypted. We've got a really nice mechanism for securing the encryption key, because otherwise it's, if you were to install the encryption key on disk, you've lost, because you just take that encryption key and decrypt the data. So we've actually got a really nice system such that the decryption key never actually persists on disk anywhere. We've got things like, super important, like detailed audit logs. This is super important for our customers. So we have these audit logs. They can export them to any system. They can do checks on them. They can see all of the requests that have, and responses that have actually come through Vault. So if they've noticed any unusual behavior, they can immediately shut down the system. Data encryption. I've never been a programmer, but I certainly know quite a few. And one of the things that's really, really hard in programming is encryption. Cryptography is very difficult. And it's very difficult because you can do 99% of everything perfectly, and that 1% that you do wrong causes a vulnerability, such that your data can be decrypted, it can be compromised, for example. Now again, the way that people used to do this traditionally was perhaps through the use of HSMs, but HSMs don't scale, so it depends on your HSM, for example, but it may do 100 cryptographic operations per second, maybe, something like this. Whereas something like Vault can do in the hundreds of thousands. So that it scales very, 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 very well. So I guess, talked about this. So you can use Vault. It's obviously going to save a lot of costs. HSMs really are expensive. Particularly highly available HSMs are even more expensive. And the idea is that we're going to reduce the risk. So one of the things that Vault will allow you to do through the API is you can send your data to Vault. Vault will encrypt the data, and it will return the ciphertext to the application, for example, and then that ciphertext can be stored, encrypted on disk or inside of a database, for example. It turns out that Vault is really good at encryption. I mean, it's something that it does very, very well. Vault itself is audited. We have the community check it. We have external auditors check that everything's been implemented correctly. So we know it's very useful, and it offloads that pressure from applications developers to have to develop data encryption themselves. We talk about data encryption being difficult. Key matter, so the keys that you actually use to encrypt data, rotating the keys, revoking the keys, managing the lifecycle of keys, that's even harder. And Vault does it all again through the use of APIs. Another thing that's really nice about Vault is you can actually have, because we have that tight control over who has access to different functions inside of Vault through the use of the access control lists, you can even have separation of duties. So for example, you may have a system that takes payment information, for example. It sends it to Vault via the API, it encrypts it, Vault then returns the encrypted data, and then that's stored inside of a database. But the system that actually takes the data and sends it to Vault can only encrypt the data, it can't decrypt it. So you can actually separate what can encrypt the data versus what can decrypt the data. So even if your web front end, for example, was compromised, all it can do is encrypt more data, which probably not too much of a problem. So again, we'll leave them anonymous, we'll just call them retail company. So what happened was they had a big data breach where a lot of the payment card information that they had inside of a database was compromised, and they tried to work out, obviously, where the vulnerability was introduced and what happened, and it was the heating system, the heating and air conditioning system that was installed onto a system was running some older version of software that had a vulnerability in it. That was compromised, and once people got onto the network, they were able to access the databases. And unfortunately, all of the information wasn't encrypted inside of the database. Now, I want to say one of the things you could do with Vault is use the API, encrypt the data, and store that in the database encrypted. So, worst case is somebody gets encrypted data, which to date people haven't broken. So again, we talk about increased productivity and reduced risk. So just to round that bit up, so everything can be driven through the API. We handle all of the key rolling, which is really hard to do. If you've got any requirements for compliance, particularly around FIPS 140-2, now I know I've given HSMs a bit of a hard time. They are expensive, they're not particularly performant, but there are times when we need it for compliance reasons. Vault can integrate with an HSM to essentially, Vault will encrypt the data, and then it will send the encrypted data to the HSM, which will sort of double encrypt it, if that makes sense, and then that's actually what gets persisted. And if you do that, that's where you get your FIPS 140-2 compliance from. Vault is very performant. It can do potentially hundreds of thousands of cryptographic operations. For some customers, that's still not enough. So the unit of measurement, if you like, of Vault is a cluster. So a cluster consists of multiple servers, it provides high availability and those kind of things. You can have multiple clusters. Some of our largest customers have 30, 35 clusters in different, in each of their data centers across the world. Now, it would be really terrible if they had to manage each one of those separately, manage the replication of data between them. That's actually one of the things that we have inside of Vault is something called performance replication, where data can be replicated across multiple clusters, so it can be accessed from different regions. Normally, you want a Vault cluster to be close to your workload. If you've got a Vault cluster in China, you don't want to be accessing it from the US or vice versa. Things like latency is important, of course. But there are some times when you don't want all of your data to be replicated. I gave a good example there. Perhaps you don't want data in the EU to leave the EU. You don't want it to be replicated to the United States or to China, for example. That's one of the things that you can actually specify in Vault is replicate all of this data apart from this EU data. For GDPR reasons, it needs to stay in region. So just some more numbers. Again, Vault was quite an interesting project. So Vault wasn't originally a customer-facing project. I find this story quite interesting. So I talked about Terraform Enterprise earlier. What you probably didn't realize, because I didn't mention it, is you've kind of already seen a demo of Vault. You just didn't realize it. All of the encryption that takes place, remember I talked about those secure variables and you can tick that box and no one can get your credentials? It's actually Vault in the background that's encrypting that data, so it's not actually persisting in plain text. And when people were trusting us with their AWS keys, which are kind of important, we didn't want to just put them in a spreadsheet or in a text file on Dropbox or something like this. So we actually took a look at the market, and we were going to buy an encryption solution, and we couldn't find one that sort of met, I should say, the requirements that we actually had. So we actually made this as an internal project, around about 2013, I think it was. And it just so happened, we were going around to customers talking about secrets management, and they were like, you should release Vault, because it does what we need in an encryption management solution. Since then, it's just gone crazy. So, again, it's got sort of 10,000 GitHub stars. Estimated about 2 trillion transactions have been processed by Vault. It's sort of difficult to tell, of course, unless every single customer was to send us their data, which we don't do. 1 million downloads a month. It's one of the most popular and widely deployed products. And again, over sort of 250 enterprise customers worldwide, which again is probably slightly out of date. So just to recap, I'll do a really brief demo, and then I'll let you all go. I'm sure you're all keen to go. The idea is we want to reduce the risk of a breach. We can't hard code secrets into plain text files anymore. It's a bad practice, always has been, and there's no need to do it anymore. You want to increase productivity. Now, again, I'm not a developer. I speak to people who are using Vault. It's a pleasant product to work with. It's a nice product to work with. It's got a very nice API. It's a very accessible product. And also, encrypt all of your data. I mean, it's an obvious thing to say. You should be encrypting your data. Why not? You can do that through Vault, through a single workflow and the API. I'm not going to go through this in every point, but every component inside an organization has different requirements from a security management solution. Your security team needs detailed audits. You need to be able to revoke secrets. You need a break glass procedure. So there is something inside of Vault, which is called sealing the Vault, whereby it seals access to the storage engine. There are times when you've got a vulnerability, you press the big red button and cut off access to the secrets while you kind of work out what it is that happened. Very, very granular control to all of the operations. Remember, even to the level of this system can encrypt data, this system can decrypt data, and they're completely separate systems. Development teams, they want something that they like to use. It's no good having a fantastic secrets management solution if nobody wants to use it because it's an unpleasant experience. I've worked with solutions whereby you have to have this big fat SDK and install an agent onto all of the systems and have it fingerprinted. And by that point, the developer's like, I give up, this is too hard, I don't want to do this. I'll just put it back in a Git repository. And the people closest to my heart, the operations team, bless them, they don't want a system that's hard to manage. They don't want to have a system that always getting phone calls, it's not performant, it's got downtime, it's timing out and all those kind of things. It's hard to upgrade, or it's difficult, and as I said, I won't talk about it, but the master key, basically, the thing that's going to encrypt your data, how do we make sure that that is secure? How can we make it easy to restart the Vault system and not have to have 10 people all wake up and provide the key material to unlock Vault and those types of things? So it needs to be usable, which it is. It's very easy to use. It needs to be scalable. I mean, Vault will scale as big as you want. It will scale horizontally, vertically. It's immense. The amount of traffic that people put through Vault, the kind of scale that Vault operates at, boggles my mind. And you need to be able to enforce. You need an audit trail of what's happening to all of your different secrets. They need to be centralized. They need to be encrypted. You need to control who has access to them. So I'm going to do a real quick demo, if I may, and then I'll give some time for questions. So let's talk about Vault. So I'm going to just quickly log into Vault. So one of the things I didn't mention is that Vault has the concept of namespaces. So the idea is that you want to offer Vault as a centralized capability because everyone should be using it. And the trouble is that every department inside of your organization maybe have different requirements and there should be separation. And my application has nothing to do with yours, so your secret should be separate from mine. The way that you authenticate is different. You use Azure, I use AWS, we should use different methods. You use databases, I'm only interested in certificates. So you can use namespaces to keep separation between all of those different things. So I'm just going to log into my particular thing. I'm going to log in here and log in here. Whoops. Come on, there we go. Third time's the charm. So this is the user interface of Vault. Now this is obviously underneath, this is driving the API, so you could do all of this through the API. I'm not going to go through every single secret engine, every type of authentication method. So I used just a simple username and password, because I wanted to identify myself as a human. I could have used LDAP, I could have used Active Directory, I could have used my GitHub token, I could use my Okta token, I could have used something else that's kind of funky and interesting. If I was a virtual machine, I was a Lambda function, I'd use AWS IAM as a method to authenticate myself, or Azure AD, or I'd use Kubernetes authentication, such that the pod comes up, says to Vault, hey, I'm in this particular namespace with this service account. Vault then checks with the Kubernetes API and says, is this true? Hopefully it says yes, and then you've authenticated. And then you get a policy. I want to show you the policies first before I show you some of the functionality. So everything inside of Vault is path-based. So it's always / this bit, / this bit. Now, I've logged in as Russ. These are some of my colleagues that also use the system. Let's pick one at random. Okay, who did I click on by accident? Jeremy. Now, it turns out that my policy says I can only access my own policy. I can't access Jeremy's policy. So I can control everything in Vault, even what I can see, what I can do as an administrator, let alone what secrets I can access. I can do both of those things. But let me actually scroll down and show you my policy, show you what that looks like real quick. So, unfortunately I can't make this bigger in Firefox. Okay, I'll just have to scroll. So the idea is it's very granular. I can say this particular path. So for this one is, I have a secret engine, which is a key value store, and there is a subfolder in that called Russ, and I've got an asterisk there. So anything in that path, I can create secrets, I can read the secrets, I can update them, and I can delete them. So I've basically got full control over that. I can change my own password as well if I wanted to. I can see my own policy. I couldn't see anyone else's policy, but I can read my own policy. I can't change my own policy because I've only got read access to it. So I can't actually change it. Probably an administrator can. I've got certain access to things in the user interface. I've got access to, I'm going to do this in a second, I'm going to generate an AWS credential right in front of your eyes in seconds. It's amazing. I've got the permission to do that. I'm going to generate a database credential right in front of your eyes in seconds. And I've got permission to do that. I don't have to have that. By default, obviously, everything is denied. If this was a blank policy, I'd have access to nothing. So I have to explicitly say what I have access to. And again, right down to the create, read, update, delete. So it's very, very, very granular. And some other things there. So with that in mind, let's just take a look at some of those secrets. So if I go into this path, secret, this is a key value store, and I go into Russ, I can see I've got a secret in here. And it's, can't quite read it. So it's value equals 1, 2, 3. Very exciting. And, you know, I've got full permission in here, so I can say, okay, I'm going to create a secret 2. And I'm going to say, I don't know, maybe I'm storing a username in there, Bob. So there we go. So I've stored that data in there as well, and I can do that. Now, remember, my policy doesn't say I have access. Oops. I broke it. Oh dear. That wasn't me. What does that say? What have I done? Anyone work in tech again?
Yeah, not possible. This URL is not categorized.
What? Anyway, the rest of my demo was really, really good. So what I would have done, and what you would have seen if, whoops, never mind. So what would have happened is, so the AWS credentials that I talked about, basically that's already pre-configured. That's already pre-configured with the necessary credentials to be able to generate credentials, if you see what I mean. So if I'd have hit a button inside of Vault, it would have talked to AWS, to the API, and said, generate credentials with this Amazon policy attached to these credentials. And those credentials would have been valid for, I think, 60 minutes. So I could have used those credentials, deployed things into AWS. I could have used it with Terraform to deploy into AWS. And then after 60 minutes, Vault would have then talked to AWS and said, kill those credentials. And it would have deleted it. In the same way it would have done for the database. if your application needs to talk to a database, it can do that programmatically. It can talk to Vault, talk to the API. It can identify itself because we have those trusted platforms that it runs on with those identity providers. It can say, hey, I'm a web server, I'm running on AWS, I need access to the database, here's my API call, and then Vault will go, yep, you are who you say you are, you have access to generate database credentials because you're a web server, and web servers are allowed to do that, and here are the database credentials, and they're valid for 30 days. After 30 days, you can renew them, but after 30 days, Vault will kill those off as well. And the idea is you have these short-lived secrets. Same with TLS certificates. I could have done that, whereby you generate a TLS certificate and it lasts for 72 hours, as opposed to the world that we're trying to get away from is, we used to have these really long-lived secrets. Like TLS certificates, how long do they live? I speak to organizations, and the first question I ask them, or one of the questions I ask them is, how long does it take to get a TLS certificate? And they're normally like, I don't know, like 6 weeks. And that's a painful process. And so what happens is when we have painful processes, it teaches bad behavior. So what happens is one of these people, we want a TLS certificate, they say, I need it for 10 years. It needs to be 10 years because this process is painful. And the next time that this needs to happen, I want to have got another job. So ideally, really long lifetimes. The trouble is the TLS certificate lasts for 10 years, and somebody steals that certificate. What happens is they can access your data or decrypt your data for 10 years. The idea is we want to move to Vault. And the idea is if I can do this automatically, programmatically, I don't even have to type anything. Once I've configured it, it just happens. I get a certificate and it lasts for 72 hours. And then if it gets compromised, okay, there's a small window where possibly there's some vulnerability. But after that, the certificate's useless. So we keep that target moving on all the time. Same with Transit. So Transit is the name of our encryption as a service solution inside of Vault. I can send data to Transit, it will encrypt it for me and return the ciphertext back. Another system might be able to decrypt that data. I can say to Vault, rotate the keys. For a lot of the secret engines, people always say, well, I've got you, because you just said that database administrators creating passwords is a bad idea, but Vault needs a root password to the database to be able to create users, drop users. So there's the point of compromise. Well, no, because the thing about Vault, one thing that Vault can do is, yes, you need to provide it some root credentials to the database. Then immediately you say to Vault, rotate those credentials, change them. So then the only thing that knows them is Vault. The DBA doesn't know them anymore because Vault's changed them inside of Vault. For all of these sort of secret engines, for most of the secret engines, Vault has that capability to rotate that secret. So sure, maybe a person knows it at the start. We've got to kind of crank that handle the first time. But then afterwards, Vault, the only thing that knows that secret is Vault. So I know probably everyone wants to go. So any questions? Thank you all so much for staying to the end.